Hello my dear friends and students. As in the series of this welding lectures, I have completed few topics which are oxygen flame welding, oxy-acetylene welding, oxy-acetylene cutting and pressure cutting. Now we will discuss what is this plasma cutting first, then we will move to the electric arc welding, which is our next topic of this session. So plasma cutting basically utilizes ionized gas jet, which is also called as plasma, a very high temperature gas jet, to cut material resistant to oxy-fuel cutting. The material which is non-ferrous in the nature or which are not easily welded with the help of oxy flame welding or oxy-fuel welding, that can be cut with the help of this plasma cutting method. So high velocity electrons are generated by arc impact gas molecules and ionize them. So this is the whole process or methodology of this plasma cutting. The ionized gas is forced through a nozzle up to 500 meter per second, and jet heats the metal and blasts the molten metal away. So in this way this molten metal will be removed away. Okay, so this is the way you are going to cut the material. Now this is more economical, more versatile and much faster in nature, means 5 to 8 times than oxy fuel cutting, and produces narrow curves, which is a kind of disadvantage for any kind of building, and smooth surface, means the quality of finish will be very higher compared to the oxy fuel cutting, and as well as it is more versatile and faster as well, means 5 to 8 times better, means faster. And heat affected zone HAZ is 1 by 3 to 1/4 of the then oxy fuel cutting, means very less area of heat affected zone will be there for plasma cutting. Maximum plate thickness is 200 mm. Maximum plate thickness will be 200 mm. Now, so this is all about plasma cutting. Now we have to jump towards the electric arc welding. Let's see what is the setup or basic circuit for arc welding. Okay. So the basic circuit of this arc welding, as you can see in the picture, this is a DC generator, DC rectifier and DC AC transformer. In out of these three you can select any one for the power supply, and this is the voltmeter to monitor your voltage, and this is the ammeter to monitor your ampere and all. So this is your electrode cable. Electrode holder is there to hold this your electrode, and this will produce a arc. Okay, and this is your workpiece cable, and this is your workpiece. So in this way you can set up your basic circuit for your arc welding, which can be used for the electric arc welding. Now let's see what is the principle of arc. An arc is generated between cathode and anode, as you can see in the picture of basic circuit, when they touch to establish the flow of current and then separated by a small distance. Okay, and 65 to 75% is heat generated at anode. Okay, this much of heat you can extract, or this can be the efficacy of the same system. If DC is used, the work is positive, the anode of the circuit, and condition is known as straight polarity. While work is negative and electrode is positive, this is a reverse polarity, or it is also called as reverse polarity. Okay, reverse RPDC. SPDC conditions are preferred, means straight polarity DC system is preferred for this electric arc welding. DCR arc welding maintain a stable arc, because DC arc welding is going to flow the current stably. Okay, so this is a stable arc and preferred for difficult tasks such as overhead welding. Overhead welding is a difficult task in the practical operation. So for stable arc, gap should be maintained. Okay, means there should be gap between the workpiece and the electrode which you have hold, as you can see in the picture. Electrode and arc, electrode and workpiece, there should be a gap between this, that should be maintained. Now manual arc welding is done with the help of shielded covered electrode. Okay, manual arc welding you can do with the help of covered electrode. Bare metal wire used in automatic or semi-automatic machine, means bare metal wire you can use for automatic and semi-automatic. Okay, non-consumable electrodes like tungsten is not consumed by arc, and a separate metal wire is used as a filler, means where you are using non-consumable electrodes, there you have to add some filler material or filler which should be consumed. Okay, so in the case of non-consumable electrode like tungsten, you have to use a separate metal wire for filler. There are three modes for metal transfer: globular, spray and short circuit. Let's see the picture of that. These are the three modes of metal transfer during the arc welding. This first one is globular. In this way, this is transfer, means your metal transfer is going on from electrode to your workpiece where you are joining. This is spray in the form of spray, and this is your short circuit. This is a short circuit current, short circuit way of metal transfer during the arc welding. Now let's discuss what are the major forces take part in metal transfer during the arc welding. First is your gravity force, second is surface tension, third is electromagnetic interaction, fourth is hydrodynamic action of plasma. Depends on which kind of electric arc welding process you are going to use. These are the major forces take part in metal transfer. So I'm stopping here for electric arc welding basics content. We will discuss the numerical part and how we can calculate and deal the numerical of electric arc welding in the upcoming session. Okay, till that time, do subscribe this YouTube channel of Engineering College Banswara for more such content of different branches of engineering like mechanical, civil, electrical engineering, computer science engineering. And if you have any doubt related to the welding, do comment in this video for any kind of query related to the welding basics. Okay, thank you so much for your patience hearing. Till that time, stay tuned with Engineering College Banswara channel. Thank you so much.